Hello and welcome in our demonstration of Testwell CTC++ Test Coverage Analyzer from VerifySoft. Testwell CTC++ Test Coverage Analyzer for C, C++, C# and Java is a powerful and easy to use code test coverage tool, which shows the parts of the code which has been executed and then tested. Testwell CTC++ can be used on host for native projects. Please refer to our other video describing our integration within the Microsoft Visual Studio IDE for more information. If you look for an efficient and easy-to-use solution for your IT projects, Testwell CTC++ is your best choice. But today, we will see how it can be used for measuring code coverage in embedded targets and microcontrollers. Its main benefits are very low instrumentation overhead, performs code coverage in all targets. It works even with smaller targets and microcontrollers, and works with all compilers and cross-compilers. We'll see how your code can be instrumented for analyzing its test coverage from within an IDE, such as MPLAB from Microchip. So, the new process to put in place in this case consists of just take the regular C and header files in order to compile and link. But here in the process we have the instrumentation phase, and this is done automatically by the integration within the IDE. All gray blue parts are used by our integration to generate the simul file, and what you just saw, it's to generate a data file from the target in order to produce the report. Today we'll see how to use Testwell CTC++ with the MPLAB toolchain from Microchip. The targets are very small, very tiny microcontrollers called the PIC family, with very small resources on RAM and ROM. And for this we will use a bitcov option for Testwell CTC++ and the coverage analysis during code execution. So the first thing we assume is that you already have installed Testwell CTC++ with the host target and called OTA and the bitcov add-ons, and you do have a license for using the tools on your PC. Then afterwards, for coupling Testwell CTC++ with the MPLAB toolchain, you will have to download the CTC++ for PIC add-on, where you will have a link between CTC and the compiler and linkers used for this architecture. Next step will be to open an example within this project and see how to get coverage results out of this project. So we took an example which is provided by Microchip, so it's part of the current distribution. If you download the tool, this project is called Blinky LEDs, and it's a very simple project, but this is enough for demonstrating how to use it with Testwell CTC++. So it's only one source file and some project setup to run on a target on a target board, for instance. So let's start this project and have a look within the source code. So as I said, this is a standard coming from Microchip. So by the way, this is a processor which is used in this example, and this is a very simple project, because as you may know, the resources on such microcontrollers are very tiny. This is a very small microcontroller. So next step now from this project is to compile and link, and then have a look to the file which will be generated by CTC call from the project. So we do have some objects files which are generated there, and we do have for Testwell CTC++ two files. Mod.sim, which is a symbolic information from all the analysis that CTC has done on your project, and mod.ox, which is an intermediate file used later on for generating the report. So we'll go back to this in a minute. So we do have an issue for the moment, because we need to add, for using Bitcov in your project, a global array, which name is CTC array, and this global array need to be inserted in one of the sources that you will compile and link in order to have access to the counter variable. So first, we'll have to know which size should be this CTC array global variable, and we have a tool for that is provided to compute what would be the size needed. So we simply need to go to the folder where we have installed and actually copy a file from the distribution, and this in this directory, now that we have the mod.ox and mod.scene files, we can easily find the size that is needed to select for a CTC array. So the command to use for that is ctc post minus capital L mon.sim the pipe symbol, and then another utility which is provided called any2mem. So this way we list out of mod.sim information for this utility that will just indicate which size is needed for CTC array. As I said, this is a very simple example, so we just need actually 1 byte for this. So we need to copy and paste this information, go back to our project, and add this declaration nearby the main statement. So for instance here. So now we can save this file and try to compile and link again, which should be leading to have success for building and no more errors. So what we have now on this directory, we have for instance here the L5 that could be or X Intel X format that could be downloaded to the target for debugging the application. So for debugging the application, now that this is instrumented binary, we want to use actually the simulator. So the simulator here is called MPLAB.sim. So from this menu, we already have selected this, because if you don't have any target board for running the application, simulator is a good tool for practicing and executing the binary. So now we should be able to run this application. So the application is running, and normally at the name of the project will tell you you should have some LED blinking somewhere on the board, but we don't have any board. We're just using the simulator, so we just rely on this example working directly. So now we can alt the execution, and we could try now to find the CTC array variable, for instance within a watch window. So here in the watch window, I can see that actually CTC array is stored at the address 0. Okay, very common, and its length is one byte only. So I need to save this this content down to the disk in order for the report tool from CTC to generate the coverage report. So how to do that with MPLAB? Actually, you can right click on the CTC array variable, and you will have to use the export table command for generating the content of this global variable using a dedicated format actually. create, for instance, mod prefix file. So let's see what inside this file, and then the next step is to convert this text file to binary for the report generator to be able to compute the coverage data. So we have for that a very simple tool which is available on the net, but you can use any means you want to convert from text to binary. Here what we are using, so again, this tool is not provided by Microchip. It's not provided from Testwell. This is up to you to find the right way to convert from text to binary. So we have this tool, which is a free tool available to convert the information. And once this is done, you can see that this file actually is containing some binary information. So this should be enough for the report generator, the Testwell CTC++ report generator, to generate the coverage data for you. So for that we prepare a script which is called a report.cmd. Just 2 lines. The first line will take the mod.bit file we just created by converting the memory dump from the MPLAB toolset, using the mod.aux intermediate file that has been created by CTC while compiling and linking, and then sending this to another utility which is called CTC to that. Then the second line will take the regular process for CT post in any kind of host for any kind of target. This is the process to create a report, and you will take the 2 files which are mandatory for that, the mod.sim, so the symbolic information for the analysis, and mod.dat, which is concrete, the real data coming from your coverage analysis. Then the coverage level, here we're using MCDC coverage level, and generating for HTML. That means that once the HTML file will be generated, it will invoke the default browser in order to navigate within the report. So let's do that. This is a report generator which has been produced. As this example is really very simple. There is no much information available, but on a real project you should have all information you need for your coverage analysis. So this is the end of our presentation and demonstration. Thank you for attending. If you are interested in getting more details, please visit our website verifysat.com, where you can get all information about our products, technical description, brochures, papers, videos, and many more material. Feel free to ask us for a free evaluation. Goodbye and thank you.